All right, good day everybody. Today we're going to tackle the topic of something called the substitution method. Now the substitution method is the second of three methods that we will use to solve systems of equations. We remember that when we have a system of equations, to solve that system means to find the values of x and y that make both equations true. For instance, if we have a system of equations like this, where you have y equals 4x minus 21 and y equals 3x plus 2, we're going to try to figure out what x value and y value will work for both equations. What is x and what is y? Now, on this system of equations, could you graph both of these equations? Sure, they're both in slope-intercept form. We could graph them, see where they intersect, and that could help us find the solution. But what we're going to do today is a different method, a different approach. What we're going to look at is, we're going to look at the fact that in this equation, y equals 4x minus 21, but y also equals 3x plus 2. So wouldn't 4x minus 21 be the same thing as 3x plus 2? If y equals one of them and y also equals the other, wouldn't they have to be equal to each other? This is called the substitution method. We're just going to substitute one of those expressions in for y, and then the point of that is we can now solve that equation for x because we don't have any y's that are bothering us anymore. All right, we're not going to finish this problem because I want to give you some context. I want to tackle this in a real-life context kind of a way. So I want to introduce you to Chuckster and his pet cat slash best friend Bison. Now, the real-life problem that we're going to tackle today is not the question, Mr. M, how can I be as cool as Chuckster? Because you can't. So just try to move along with your life and be happy anyways. But the problem that we're going to try to solve is if together Chuckster and Bison are 35 years old and Chuckster's age is 15 years older than Bison's, how old is Chuckster and how old is Bison? So how are we going to do this problem? We're going to set up a system of equations. We're going to let x represent Chuckster's age, and we're going to let y represent Bison's age. So what can we do with this? Well, if together Chuckster and Bison are 35 years old, that means the sum of their two ages is 35. And if Chuckster's age is 15 years older than Bison's, then x, you would have to do y plus 15 to get x. So there's our system of equations. Now, I'm going to line them up like this so that we can see here something about this system. Notice that if x is equal to itself, which it of course is, and if x is also equal to y plus 15, then I could put y plus 15 into the first equation where that x is. Why would I do that? Because it would substitute in there to give me an equation that is easier to solve. I can solve y plus 15 plus y equals 35 by simplifying it, because if I have y and y, that's 2y. And then I'm just going to solve this equation like we know how to do. Take away 15 from both sides, and then I'll have 2y equals 20, and then I'm going to divide by 2 on both sides, and I get y equals 10. So now I have my system of equations solved. I know that Bison is 10 years old. Oh wait, I didn't solve the whole system yet. I need to know how old Chuckster is. So in order to do that, what do I have to do? I have to figure out if Chuckster is 15 more than 10 years old, because y is 10, then Chuckster's 25 years old. So I kind of had to substitute that 10 in to my original system of equations to be able to get x and y for this situation. All right, this is called the substitution method. All right, the substitution method means take that x and replace it with a y plus 15 so that you can solve for y. So how about this one? The sum of two numbers is 40. I got two mystery numbers. What are they? I don't know, but they add up to 40. Their difference is 4. What are these two mystery numbers? Well, if the sum is 40 and the difference is 4, what can we do to make a substitution? Well, if x plus y is 40, then x would be 40 minus y. Whatever y is, you would take it away from 40, and that would tell you what x is. And if that's true, then I can take this x and I can put a 40 minus y where that x was. I'm just subbing it in there. I'm swapping it out. I'm plugging it in. This is the substitution method. Now I have an equation with just y's in it, and I can solve this equation because if I have a minus y, that's minus 2y. And now I just subtract 40 from both sides, and I get minus 2y equals negative 36. And then I do divided by negative 2, divided by negative 2, and I get y equals positive 18. Am I done? Not quite, because I know y, but I don't know x yet. So now I have to substitute this back into the original equation. And now I know that it's x plus y is 40, but y is 18, so it's x plus 18 equals 40, and then you just subtract 18 from 40 to get x equals 22. Now we have solved the system of equations, and our solution is our two mystery numbers are 22 and 18. All right, this is the substitution method, and you can do this, and you don't have to draw any graphs, you don't have to know any slopes or intercepts. Whew. This might be a helpful thing to know, and that's why we're learning it. Here's a practice problem if you want to give it a try on your own. You can pause this video, write it down, and try to tackle this. And if you want to know the answer, ask me tomorrow in class. All right, see you soon. Adios.